Hello everyone, welcome back to our last part of this chapter, chapter 9, Differentiation. In this chapter, this last part of it comprises the application of dy dx, the third one, which is the last one, application. Now, in the following video comprises of, we're going to cover 4 different applications. To start with the first application, that would be the gradient for a curve. The gradient of the curve to form a tangent line. Gradient of a curve to form a tangent line. That would be, I think it's too short. I will try to illustrate it over a graph. Then I can have working over this side. So if you were to have a graph, this is positive y direction goes up, 0 here. To the right is my positive x direction. Regardless of whether it's a U curve or an N curve, whether it's curve up or curve down, for this purpose I would say I have a U curve. In my previous video, I show you on what does it mean by dy dx. So here I'm going to use it. If you realize up to this moment, differentiation is all about gradient, general equation, the gradient at different points. Say for example, the gradient at point A compared with gradient at point B and compared with gradient at point C, we use same color. The gradient, meaning the point or the line that touches 90 degrees at this particular point, says A, is a negative value as compared to C, one value. Here, your dy over dx would be less than 0. Whereas here, dy over dx is more than 0. Now what happened here, this is what happened when y is a constant. When y is a constant number, is a line that touches at point B, 90 degrees. What happened to here, my dy dx is equivalent to 2, which is the first equation in my previous part of video. You get to see that gradient changes from negative to 0 and to positive. If I were to get the general equation of tangent, meaning dy dx, at different point, you will find that the gradient changes at different location. Say for example, if you were given the equation, or maybe I want to use another equation despite our previous question, maybe 3 equals to, says, maybe 3x squared plus 6 maybe. Now what happened is, this is an equation. If I want to find general equation for gradient, meaning what's the dy dx, changes of y to the gradient of this curve with 6x plus, 6x, there's no plus because that's all about it. 6x. 3 times 2 is 6. This is a constant, you get 0. So, you will find that the x value determines the gradient. when the value changes from one point to another, says from this point, well, of course, this is not a curve that represents this equation, but if you have a curve that looks like this, and this is gradient, different x position, the gradient will be different. Find the value of d by dx. You want to ask to find the gradient d by dx. Is a gradient, which is a gradient d by dx. When x is 2. So easily, therefore, d by dx will be equals to 12. You just substitute the value into here and you get the answer. Quite easily done. If you're given a coordinate, then you just substitute x into the equation, you get the answer. Simple. Now, if you want to get what's the equation of this tangent, then you need to follow a general equation of gradient, of course, whereby your gradient equals to y2 minus y1, of course, that you have learned in junior high, over x2 minus x1. If you were to simplify this equation, it turns out that y2 minus y1 will be equals to m times x2 minus x1. So now, for this case, if you were told that this equation passed through a point, if the equation passed through a point, if the curve passed through a point, maybe 2, 3, maybe 2, 4, random point, you need to ask to find the tangent equation. Tangent equation. The tangent equation. Equation for tangent. The tangent equation. Equation for tangent. That would be so simple because you just put into equation. You may take this value as y1, then your equation y minus your, this is my y1, maybe we use another color. This is the number I want to put in, minus 4 will be equals to my gradient. My gradient when x is 2, that would be 12. 12 times x minus 2. Simplify this equation, therefore my equation for tangent, t represents, subscript t represents tangent, will be equals to 12x plus minus subtract 20. Quite easily done. This is how you make use of the d by dx to get an equation of tangent. But there are instances when you are asked to find equation for normal. What happened to the normal equation? Then you need to refresh your mind. You go back to what you have learned in chapter 6 from 4, whereby your m tangent times with the m normal is supposed to be equals to -1. At this point, SPM, or in SPM, sorry, you doesn't need to prove this equation. You just need to use it. You just know it. Whereby the gradient of tangent obtained by d by dx times with the normal gradient is equal to -1. So if you were to know what is the gradient for tangent, you'll be able to get what is mn, meaning the gradient for normal. So you have to solve it. I'm not going to show you how to do it because you should know it by now, or you will learn it in chapter 6 from 4. Now next, I will talk about turning point. Here is actually turning point. Turning point is also called turning point. It's also called turning point. because this is a time when the gradient changes from negative to positive. So this point would be my turning point. How am I going to make use of it? How can I make use of dy dx to get the turning point? You may you may go back to my previous video in chapter 3. You use completing square. But completing square is one method. You could make use of dy dx to get the turning point. Turning point. Turning point, or some question says, is it maximum or minimum? The nature of the turning point. First thing come to your mind, whenever there's a turning point, dy dx, it has to obey this condition equal to 0. This is what it meant. Whenever it says it's a turning point, dy dx equal to 0. Is it maximum or minimum? Dy dx equal to 0. Because when dy dx equal to 0, in my previous page, this is what happened here. When dy dx equal to 0, this is what happened. That's why it's equal to 0. Right? Now, all you need to do is to get the equation and you find what is its gradient. Say for example, I work by example. It's easy that way. Example. Now I would like to, I used to do it this way, giving a tutorial. You are supposed to attend formal lecture, formal class session at your school. So I don't expect the viewer to skip class. You still need to attend formal class. It's meant to help you out, or perhaps you read on my video before you attend any formal class. So, say for example, you give me an equation, y is equals to, says 2x cubed, interesting, 3, minus 5x minus 3, subtract 3. Okay? You are asked to look for the turning point. First, look for turning point, find turning point, and then 2, determine if it is positive, or determine if it is maximum or minimum. Well, it's quite often you get to have this kind of question. So let's solve the first problem. Find so limited, you were given so limited information, how are you going to get it? So strategy, find turning point, you differentiate this equation, equate to 0, then you get your x. Once you get your x, you substitute back into the equation, you get your y. And that's how I'm going to get my turning point. So start with my dy dx would therefore be, I expect you to be good enough to be at this point, minus 5, so straight away look at it, you can get the answer. At turning point, dy dx equals 0. You get some marks over here during SPM. So therefore, okay, this case equals 0. This is a very rare occasion because you're dealing with a cube, meaning it should have 2 turning points, 1, 2 of a curve. So that's why you have a 2 here. So therefore my x would be equals to square root of plus or minus, they're supposed to answer because square root of answer, 5 over 6. Could be a positive 5 over 6 or negative 5 over 6. So 2 value. Then what you could do is when x is equals to square root of 5 over 6, your y will be equals to 2 5 over 6 square root 5 over 6 squared minus 5 times square root of 5 over 6 excuse me, minus 3. Or you use your calculator, you eventually get a value of y. Now, next thing, which is something that I will need to want to bring up, is how are you going to tell if the point that you get is maximum or minimum? A side note here. In order to tell if your point is positive of the nature, maximum or minimum, what you need to do is you get the second derivative, meaning you differentiate another time. It says you have equation y is equals to equation like maybe 2x cubed minus 5x squared. Okay, first derivative is dy dx. That will be 6x squared minus 10x. You equate this equals 0, you get coordinate for turning point. You equate this is 0. But if you want to determine if the coordinate you obtain is maximum or minimum, all you need to do is you differentiate this equation another time. d2y over dx squared will be equals to 12x minus 10. So you still have an unknown. Then what you do is you substitute the value, the x value, the coordinate you obtain from here, you substitute the x into here. If the value is greater than 0, therefore it would be a u-curve pointing upwards, is why positive, and therefore you will get a minimum point. So you will know, oh, okay, that point is minimum. The same is true. What happened when d2y dx squared is less than 0? If it were less than 0, then that's a time where you get n curve less than 0 points towards negative. Therefore, your point, your coordinate is maximum. This is a maximum point when d2y dx squared less than 0. What I have here is not a design question, that's why the answer, this is one coordinate, and you may work out with the x negative, work out with x equals to, when it's negative, root 5 over 6, put into equation, you get your y, y2, this is x2, and then you differentiate this for another time, part 2, so what you do is you d2y over dx squared is equals to 12x. So you substitute this value into here. When x is root 5 over 6 is a positive value, you find that your d2y over dx squared is less than 0. So when it's less than 0, I know this coordinate, therefore it's a maximum. It's a maximum. Likewise, when x is equals to negative square root of 5 over 6, which is a negative number, my d2y over dx squared negative less than 0. Sorry, this is a positive, so this would be more than 0. Oops. I made a mistake here. Apologize for that. More than 0. If more than 0, therefore this is a minimum point. When this is less than 0, therefore this coordinate is maximum. Okay, we'll show you the concept. Of course, you may use completing square, but completing square just up to the turning point. And there's another method I'm going to show you later, which is to make a table to get a small change. But that would be I'm going to show you slightly later. Next page, perhaps. I will show you on what happened when a small change, a maximum minimum point, by using a table. I mean, you tabulate it and then you get the answer. Say, for example, if I have an equation maybe it's 2, example 1, maybe my example 2, hope it helps you to pinpoint your question later. If you want to point your question, you may put into a comment. Question 2. Find the coordinate says y is equals to x3 minus 3x squared. Okay, determine whether each turning point is maximum or minimum. So you have 3, so you will expect, find turning point, and then whether it's possible minimum. So to start off with, simple concept, which is dy dx equals 0. So dy dx equals to 3x squared minus 6x. Okay, at turning point, so this is general equation for gradient. At turning point, dy over dx must be equal to 0. So you equate to 0. So therefore 3x times x minus 2 will equal to 0. I simplify this equation. Common factor is 3x, so I factorize it. This is what I get. So therefore, in order to get 0, x equals 0 or x equals to 2. So I have 2 points. In order to get turning point, when x equals 0, my y will be equals to 0. When x equals 2, my y equals to 2 cubed minus 3 times 2 squared. So therefore, my y will be equals to 8 minus 12 minus negative 4. So I have two coordinates, 0, 0, 2, negative 4. Now how would I tell if this at point 0, 0? How can I tell whether it's positive or negative? Another method of it is use a small change. Let me do it here. Let's say I have value of x, value of dy dx, value of dy dx. When my number at 0, what happened? When it's 0, my value of my value of dy dx is 0 because this is the time when the gradient is 0, and this is the time when my gradient is a flat line, so it's 0. So what happened before 0 and after 0? Before 0, say a number, before 0, a small change, 0.1 maybe. Sometimes 0.1 could be huge. You want it 0.01 if you want it, 0.01 sometimes. So 0.01, the number would be, put in the calculator, I calculated earlier, dy dx would be what? 0.63, which is more than 0. Therefore, it is, goes up positive. And the value smaller, or next value of 0 is 0.1. If this number is too big, sometimes you get the same sign. What you do, you make it smaller by one order, 0.01, but I'm using 0.1. Here is negative 0.57, which is negative, less than 0. Therefore, my graph should be, so from positive, 0, negative, so this point, therefore this point, the coordinate of 0, 0 is a maximum point. This is quite a tedious work because you need to get a table, substitute value, and then know the sketch. So d2y dx squared will still be a best of choice. But then of course you need to work out with the next coordinate, otherwise it's incomplete. Well, if you work it out correctly, next point of 2 and negative 4 is supposed to be a minimum. So 2, the number before 2 is 1.9, after 2 is 2.1, 2.1, oh, no, this is not the color not right, it's 2.1, and you substitute into a calculator, 1.9, this is the time when you get 0, it's turning point. This is the time you get negative 0.57 of d by dx, that's less than 0, and this is the time when you get 0.63, it's more than 0, and the sign that would be down, negative 0, goes up, a tangent line at this point is what it meant, and therefore the point 2, negative 4, you know, is the minimum point. So this is how this method, you can make use of two different methods. One is d2y dx squared, while the other would be the second derivative, which I personally prefer to use it, unless the question specify that you need to use a table. Unless they specify that you need to use a table, otherwise I would personally prefer d2y dx squared because it's faster for me to get to it. Last part would be on a small changes. The small changes would be a method used to estimate a value without using a calculator. That's the wonder of dy dx. Say for example, maybe the last one, it's a third, small changes. Now small changes, general equation for it would be my dy over dx is equivalent, approximately equals to del y over delta x. Or maybe, some student, they prefer to use it this way. It shouldn't be any problem in SPM because it's change of y, change of x. Right one would be a del y over del x. You may use either sign, they are equivalent. So how do you use it? Normally you ask, what's the small change of y or small change of x? Say for example, let me illustrate it using graph form. I were to have y 0x. If you have a graph that looks from, well, here, a small change of number, maybe here to here. Maybe this is x1, progress to x2. x1 correspond to value y1, x2 correspond to value y2. And if this changes is tiny enough, the small changes and is small enough, therefore you assume instead of a curve, you assume it to be a straight line. I repeat, if the changes x1 to x2 is small enough, a curve would be actually assumed. You may actually assume this line to be a straight line instead of curved line. Because of that, therefore the gradient here, if you have a triangle, you have a gradient here, therefore this gradient, therefore your dy over dx is approximately equals to the small change of y over small change of x. Let me give you an example. You were told that the value of estimate the value given y is equals to 16 over 4x. Okay. First part, find the value dy over dx when x is equals to 2. That's the gradient of 2. Second part, estimate. When it comes to estimate, you are not allowed to use calculator. 1.98 power 4. Normally you thought that you need to calculator without calculating solve it, but you may use actually to use small changes, do it. Now first part is pretty straightforward. To have this kind of equation, you want to simplify into single line, -4. There's one line instead of denominator. Otherwise, you might thought that you need to use a UV. It doesn't need U over V quotient. No, it's not a quotient. You just put it as equation. Then straight away, you dy dx. Next stage is dy dx. Therefore, it's negative 64 over -1 5. Okay. Oh, sorry, it's not 5 here. It should be x power 5. What happened? Okay, yeah. X power 5. So when x equals to 2, so therefore my dy over dx, put into here, 2 power 5 turns out to be negative Then estimate. This is the fun part, because in order for you to estimate this part, you need to refer back to the main concept in the curve. Gradient, when the changes of x is small enough, or the changes of y is small enough, is small in 1 in 100 or 1 in 1,000. So the curve would be a straight line. You will assume it to be a straight line, and therefore the gradient dy dx is equivalent to a small change of dy dx. So to solve this question, first of all, you need to find out second part. 2 changes to 1.98. So what's my small changes? Small change of x. Change of x is now final minus initial. This is a final value. Final subtract initial. So therefore it turns out to be a negative number. Negative 0.02, meaning it's shrink by negative 0.02. So therefore I have dy dx already. I have del x already. Now next you're going to get small change of y. It will be easy now, because now my small change of y will be dy dx, which is negative 2 times del x, negative 0.02. Then turns out to be negative positive, so 0.04. It's quite confusing about this line. Let me erase off this line. Oh, dy dx is minus 2. dy over dx equals to minus 2. Okay, so here would therefore negative 0.04. If I were to have my dy dx equal to 0.4, next thing you do is you estimate this value. So when x equals to 2, y will be equals to 1. So therefore 16 over 1.98 power 4 will therefore equals to power 4, therefore be equals to my y plus small change of y, which is now 1 plus 0.04 plus 0.04. 0.04, and it turns out to be 1.04. So how do I get this? Why do I need this? Especially this line. Where does it come in? Now we refer to the previous page here. In order to get y2, which is my new value, my y2 will be actually y1 plus a small change of y, which is from here goes up, is a small change of y. So this is here. Bring it over, over here. That's why I need to do that. So that's why I will need small change of x, so that I need to sum it with my original value of y. You might need to refresh your mind a little bit. You may want to watch it over, you watch it a few times before you would do other question. And if any other question, you may of course refer and see if you can get any insight in what I'm trying to show you. And I hope it helps you in preparation for your SPM. Good luck. Like my video. There are a few things that you could do. One would be to like my video. You press on the thumbs up button down there, and it won't cost you a single cent. It won't cost you anything. Or perhaps you would walk extra miles by sharing this video to your friends through your friend, Facebook, Twitter, any social media site. The number of likes, the numbers of views increases over time would definitely encourage me to make more video to help anyone out there. Like my video, share my video, my YouTube video, and I hope you enjoy watching the rest of my video in my YouTube channel. Have a great day ahead. Hope to see you again.